Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Miss Ruchika welcoming all my grade 10 elite math students back to school. And in today's session, we are covering from term 1 the first lesson, which is module 13, lesson 1, Trigonometric Identities. So let's dive into the video and see what you're learning today. And before we continue, a humble request, a kind reminder to like, share, and subscribe to my channel if you hadn't till now. Moving on, our learning objectives for the day would be to find trigonometric values by using trigonometric identities and to simplify trigonometric expressions by using trigonometric identities. Before we even begin the lesson, I want to just give you a flow chart which shows the different types of 5 trigonometric identities that you will be working on. The first one that we will see today is called reciprocal. Reciprocal. Just excuse me for the overwriting. Let me correct it. Reciprocal. Yes, reciprocal identities. So reciprocal identities, as the name suggests, you are going to take a reciprocal. That means you are going to interchange the numerator and denominator. Then the quotient identities. Question tells you that you are going to take division. It will involve division. This will involve reciprocal, you already know. So these will be ways of remembering these identities. Next one would be Pythagorean identity. So somewhere it will be related to your Pythagoras theorem, and because we are talking about trigonometry, it will be relating to Pythagorean theorem in trigonometric form. Then we have cofunction identities, and last but not the least we will have odd even identities. So I've just given you a quick summary of the 5 types of identities that we'll be working on. So let's start with the first one, which is reciprocal identity. As the name suggests, reciprocal identity is coming from the reciprocal. So the 3 basic trigonometric ratios, sine, cos, tan. So SOHCAHTOA. This is very important. So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So if you take reciprocal of all these 3, what you get is hypotenuse over opposite, hypotenuse over adjacent, and hypotenuse adjacent over opposite. So these will be called as cosecant, secant, and cot. So cosecant is the reciprocal of sine. So this is the relationship. They are reciprocal of each other. Reciprocal means you change the numerator denominator. Secant is the reciprocal of cos, and cot is the reciprocal of tan. So these are the reciprocal identities, and they are together called the reciprocal trigonometric functions. So if you take them together, then you can say that cosecant is the reciprocal of sine, secant is the reciprocal of cos, cot is the reciprocal of tan, or otherwise sine is the reciprocal of cosecant, cos is the reciprocal of secant, or tan is the reciprocal of cot. So these 6 are called the reciprocal trigonometric identities, and you can use them to solve problems to simplify trigonometric expressions. Let's see an example how we can use them. Let's do an example on the reciprocal identity. Cosecant is given to you as 7 by 4. You have to find sine. Now what is the relationship between cosecant and sine? They are reciprocal of each other. So can I say that sine theta would be 1 over cosecant theta by reciprocal identity? So that's the reciprocal of 7 by 4. So 7 by 4, if you take reciprocal, you interchange numerator and denominator. Means 7 will come down, 4 will go up. So it will become 4 over 7. Now we need to use quotient identity also for question number B part. Let's see how we can solve. Cot is given to you, sine is given to you, you need to find cosecant. Now what is the definition of cot? Cot x is cosecant x over sine x. So you divide them both to get the answer. So how do you get cosecant? You get cosecant by multiplying cot with sine. So you put the values. Cot is given to you 2 by square root 5. Sine is given to you square root 5 by 3. Cosecant would be multiplication of these two. So multiply, square root 5 is going to cancel and you are left with 2 over 3. So this is the value of cos. So which identity we used? We used the quotient identity. Quotient identity tells you you are dividing. So similarly for tan you were dividing sine by cos, and for cot you were dividing cos by sine. Why? Because they both are just the reciprocal. So your trigonometric identity which is under question would be these under the red box. You have to learn these identities so that you can use them for solving questions. Next, let's do this question. Very simple. Secant is given to you. You need to find cos. So you know cos x is reciprocal of sec x or secant x. So secant x is 5 over 3. So reciprocal of 5 over 3 means 5 will go down, 3 will go up. So 3 by 5 is the answer. Next is cosecant is given, secant is given, you need to find tan. Now you will use quotient identity. Tan is sine divided by cos. Is cos given? No. Is sine given? No. But is its reciprocal given? Yes. So can I say sine would be 1 over cosecant and cos would be 1 over secant? So you take the reciprocal, this is 7 over 25, this is 24 over 25. Now you have these two, sine and cos, so divide them to get tan. So tan of beta would be 7 over 25 multiplied with 25 over 24. So what will cancel? 25. So 7 over 24 is the answer. So that's your correct answer. I hope you've understood very well about reciprocal and quotient identity. Let's go to Pythagorean now. So for Pythagorean identity, we need a unit circle, and on this unit circle, you need a point Pxy so that the x coordinate is x and the y coordinate is y. So this is the point x comma y on the unit circle. Now, if you take the radius 1, because it is a unit circle, means radius is equal to 1, and you take the angle theta, then you can write for this right angle triangle using Pythagoras theorem, x square plus y square is equal to 1 square. Therefore, it is a unit circle. Its equation is this. Now from here you can write for the angle cos theta as x and sine theta as y. So the identity of Pythagorean first one would become sine square plus cos square equal to 1. In a similar way, you can write the second identity by dividing by cos square as 1 plus tan square equal to secant square, and the last one by dividing by sine square, which is 1 plus cot square equal to cosecant square. So overall, the three identities that you need to learn for Pythagorean, very important. We are going to use these identities throughout, are number 1, 2 and 3. So sine square plus cos square equal to 1, 1 plus tan square equal to secant square, and 1 plus reciprocal of tan cot square is equal to cosecant square. So these are the three identities. Let's see a question how we can solve using them. So here you are given tan value, tan of theta is minus 8. You are given sine value, sine of theta is positive, and you have to find both of them. So let's use Pythagorean. For Pythagorean, we know the identity which connects tan is 1 plus tan square equal to secant square. So you put the value of tan and you get secant value from here, which is 65. Now take the square root. So plus 65, because it is first quadrant, you are taking the positive value, and now you take reciprocal of secant, which is cos, because you need the cos value. So cos would come out to be this much. Now If cos you have and you need to find sine, what will you do? You will again go to Pythagorean identity, this time to the first one. And because sine is positive, cos must be negative. So that tan is also negative. So cos would be negative this value. Now again, you will use the questioned identity along with you can also use the Pythagorean identity to get your sine theta, which is this value. So you have got both sine and cos theta. Now try these questions as your homework. It is going to be solved in a similar manner, and then you can check your answer from the presentation as this for 2A and this for 2B. Okay, next identity that we are doing is identity number 4, cofunction identity. Now this gives a relationship between trigonometric function based on complementary angles. So when I say complementary angles, I mean two angles whose sum is complementary, that is 90 degree. For example, alpha plus beta. Here the two angles alpha and beta, when you add them, they will always give 90 degree because it's a right angle triangle. So they are complementary or cofunction angles. So therefore the cofunction thing says that sine and cos are cofunction identities. So means if you write sine of alpha, it is cos of pi by 2 or 90 minus alpha because they are complementary. So alpha plus beta is 90. In radian, it is pi by 2. Similarly, you can write for cos. Cos is the cofunction identity or complementary identity of sine. So cos of alpha is sine of pi by 2 minus alpha. Next is for cot and tan. They also share the same relationship. Cot is tan complement or cot alpha is tan pi by 2 minus alpha. So all your cofunction identities, 6 of them are there, in totality comes out to this. So what we can say, let's just summarize from number 1 and number 2. We can say sine theta and cos theta are complementary. Complementary what? Trigonometric ratios or cofunction identities. Tan and cot similarly are complementary trigonometric identities. Similarly, secant and cosecant are complementary. So secant is cosecant pi by 2 minus theta. This is how you will remember them. Let's now do the last one, which is odd even identity, and after this we will go to solving some question. Again we are back to the unit circle. Again we are taking a point x comma y and an angle alpha such that the y coordinate is sine and the x coordinate is cos. Now, odd and even says whether the result is going to be a negative or a positive value. So if it is an odd function, it will always give you odd value or negative value. If it is an even function, it is going to give you same or positive value. So here what do you recall? That a function is even if for every x in the domain of f of minus x means if you input negative value, the result is still positive, then it is an even function. For example, cos. When you put cos of a negative angle also, it will still give you a positive result. Similarly, if cos of minus x is put, it is going to give you cos x only. And odd is opposite, where you put negative value and the result is negative. So negative of f of x. So very simple. Sine is a negative or a odd function. Cosecant, its reciprocal, is also odd function. Cosecant is even function, so its reciprocal is also even. So the two odd functions are highlighted here and the even function is highlighted with blue. So you have to remember which is odd, which is even, so that when you take the negative of the angle, you can simplify using this property. Let's take a question now. Okay, so first look at the question and you should be able to identify that this is a question on cofunction identity. Why? Because you see the angle theta minus pi by 2. Now, generally, the angle which is there in cofunction is pi by 2 minus theta. So we have to change the angle by a negative sign. Very important to observe. Okay, so I can write cot of this as negative of this. Now, cot of a negative angle is going to give you negative result because it's an odd function. This is very important step. So cot of the negative angle gives you negative result. Now cot of pi by 2 minus theta is nothing but tan. So this is negative of 1.28. Very easy question. Just you have to be careful for the sign while solving. Let's do one more. Now you need to find cos. So cos, again you will take negative sign, but here if you see, cos is an even function, so its result would be even, which is sin x, or negative 0.37. So this is how you apply cofunction and odd even identities together. Now you can also use all these identities that you've learned, the 5 of them, namely reciprocal, questioned, Pythagorean, cofunction, odd and even, to simplify trigonometric ratio. So let's do one last question before we complete this video on simplification. So here you have to simplify this. The first and the most basic rule is to convert everything into sine and cos. So we know cosecant is reciprocal of sine, secant is reciprocal of cos, and cot is questioned of cos and sine. So you convert everything into sine and cos, take the LCM, multiply and simplify. So the numerator becomes 1 minus cosecant square. Now 1 minus cosecant square, because the power is 2, will take Pythagorean identity and one sign will cancel. So you're just left with sine over cos, which is tan. So the simplified form is tan. Now if you see carefully what has been done here, you were given a big expression, you have converted into a simple small one expression, and in the process you used reciprocal identity, quotient identity, Pythagorean identity. So you use a mix of the identity. So our learning objective number 2 of this video was to simplify using these identities. So we have just met them, and just to give you a thorough practice, one last question. Again, we are going to convert secant, tan into sine and cos. So convert and see what you get. Simplify and you get Pythagorean. Now 1 minus sine square. This is a indication. Power 2 means you can use cos and it will reduce by 1. So only cos x is left, and that's the simplification. So that's all for the session today. I know it's a long video. It has been made with a lot of effort. So please appreciate that effort by subscribing to the channel and by putting your queries and questions in the comment section. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye, students.